All right, everybody, welcome back to Zebra MD podcast. There has been a hiatus, and I was doing something very important in my family life. Some very exciting news on that front. But now we are back. Today, I have a very exciting guest, Dr. Mohammed Turki. He is a third year gastroenterology fellow who already has innovated his own device, which is now undergoing human clinical trials. He's going to be a future advanced endoscopist and he's going to start his training soon in July of this year. So, without any more chit chat, just let's get into it and learn from his journey. So, Dr. Turkey, welcome to the podcast.
Hi, thank you for having me. I've been actually listening to your podcast for quite a while, so I'm pretty excited to be here.
Thank you. Thank you. Um, so, before we get started, can you tell us a little bit more about your journey in GI leading up to your device?
Sure. So I would say my journey as an innovator started a little bit earlier than in medicine. Back home, we had the opportunity to do some pre-engineering studies in high school, which I elected to do. And that gave me kind of the ground knowledge just to be able to communicate with engineers and speak the same language as they do. Then when I came to the US, my goal was still to work in innovation, and all my career decisions were led by that. So initially, I was doing research at Mount Sinai, and at that time, I was doing 3D printing of mitral valves for training. And when I was there, my idea was to go into surgery, but I slowly shifted my thoughts because I was discovering that most of the innovation was in the interventional procedure rather than in surgical procedures. And I was thinking about doing cardiology for that. And I actually did pre-matching cardiology. But then while I pre-matched in cardiology, I understood that the curve of innovation in cardiology was kind of almost done, but now we are in an area where we are discovering a new curve in GI, and that's how I changed my mind into GI. So GI came a little bit late, but it came drawn by innovation. And later on, when I went to Marshall University, like my goal was to innovate since day one. Like I knew that's what I wanted to do. So even when I enter an endoscopy room or when I'm learning new procedure, learning about new disease, anything like that, it's always in my mind. So it's really, my journey is kind of led by that, but I've never done anything tangible until more recently. So it was always like a thought, and I had the opportunity to develop more recently.
That's very impressive that you started so early about, your innovation and how you wanted to go about it. One question that always comes to mind is how do you find these ideas? As a backdrop, we had our last guest who had this astute idea of carrying around a notebook, which he called the pain points. So everything that's painful, which is a lot of things sometimes when you're, working in endoscopy, and he would note things down and keep thinking how he can innovate on them. Do you have some tips like that?
I actually do have a notebook like that too. Yeah.
Excellent. Yeah.
It's the same notebook where I put my DD questions, where I put my new notes and things like that. But on the other end, whenever I have an idea, I put it down. And there are probably 30 or 40 ideas. And hopefully from that will emerge one or two successful ones.
So once you have an idea, what next?
Yeah. Well, I like this question. And when I was talking with you, I thought I'm going to try to really talk more to fellows or to people who are really making their own device. I'll try to keep it less technical and more practical if it's okay with you.
Of course. Yeah.
So let's say you have an idea, and I want to emphasize that it cannot come early enough. And the reason for that, your mind is going to shift multiple times throughout your career. What is a pain point for you as a trainee is not the same pain point you'll discover when you are scoping after 10 years or 20 years, and it's very different. And when you are scoping at 10 years, you have so many good habits or new habits that you won't realize anymore that what you're doing is kind of complicated or you can simplify it because you just got used to it and you performed so much in it. So being a first year fellow is also as important as being in your career 30 years later. And that's where my first device came from, right? Like any GI fellow, I was having some trouble intubating for my first few scopes, and I was thinking, how can we simplify this and make it safer? So what I'm emphasizing here, there is no time in your career that is too early to start. Now you have an idea. There are few ways to go about it. You can work on your idea on your own
Hmm.
and try to progress with it or partner with your university. Sometimes you're bound by a contract that forces you to go one way or another, but most of the time you can do either way. There is an office in every university and big hospitals. You won't probably find it in smaller community hospital, but it's called Tech Transfer Office.
Hmm.
And I hate their name because their name already sounds like they are transferring your technology and taking it away from you. But
Right.
that's really not their purpose. So, tech transfer office in every university and every major hospital is there to assist you. So, you go to them with your idea as advanced as you can, but not necessarily. It can be even on a napkin. And you talk with them, and they will tell you if they are interested in supporting it or no. And the goal you want to have from there, are you going to have the support of the university? And you have to understand that if the university is supporting you, it means money, legal counseling, probably with a trial, things like that. Or will they release it to you? And then they say, this is not an area where we'd like to invest our resources, but we release it for you. And the idea is yours. We won't claim it at all in the future. And but you can go by, but unfortunately, you'll also have to rely on your own money and your own time and things like that. So there are two ways to go. Usually, the tech transfer office will decide for you. One famous failure of tech transfer office was in SUNY upstate or downstate. They released the MRI. They didn't take it. Like the person who was inventing the MRI went to them. They said, "Yeah, this is gonna be too costly. Probably won't get anywhere," and they released it. This is one of the big failures.
Wow.
So
Wow.
you don't really know how these discussion goes. Like you think you have the best idea of the scenery, and they might not invest in it, or you might have a smaller ones, and they say, "Yeah, why not?" So. It really depends on the agent who's there, but this is, I would say, your first step to be practical.
Right.
Now, other resources I used before going to my tech transfer office, I tried to develop a little bit on my own. And the reason I did that is I had the fear and the lack of knowledge of what the tech transfer does. And I wanted to protect myself before going to them, which was an unjustified fear. But we all know the minute you start talking about a device, everyone will think corporate evil is going to steal it from you. That's the advice everyone is giving you.
Right.
But if you take a minute and think about it, not a single person will give you that advice if they did innovation before. That's kind of the layman advice. But in reality, the good advice will come from people who innovated, and most of them would have partnered with the universities and their tech transfer. So what I did is I went to a company, local company here that have 3D printers. I went with my idea on a napkin. I paid them out of pocket as a fellow, and we kind of improved my design a little bit. And we did 3D printing of a couple of prototypes. That was my first step. The second thing I did, and this is why I want to do this and to protect myself, I contacted the lawyer, and they have this package where you go through a couple of classes and you write the patent, and they give you 1 hour of corrections. And I did that, it's called PCK. I did that because for me it was the cheapest option to go by. Not necessarily the best one to go because you can expose yourself to bigger problems once you grow. And unfortunately, I'm discovering that now. But at that time, I didn't have money, so I went with that. So I wrote my own patent, gave it to them. They didn't need to do much corrections, and they gave me a patent. Now, once I had the patent, I became a little bit more vocal about my invention locally, and I spoke with my university. What we have special in my university, so my university, I would describe it as a mid-size, average university in the US. It's pretty representative of what you have. My university had partnered with a local company called Intermed Lab, and they are specialized in device innovation. And the way you go through the tech transfer office and you speak with this company and you pitch your idea. If they like it, they invest in it. I was lucky enough to convince them, and we went by it. But if you don't have this kind of partnership in university, it's probably actually bigger than mine, and they probably partnered with the local engineering schools and their local labs.
Mm.
And you have a lot of people sitting doing PhDs, trying to do end of year projects and summer school and things like that, and they are craving for ideas. If you just go introduce yourself to your engineering school, I promise you there will be people trying to help you. And as a fellow, you don't necessarily have to pay them. You can give equity, you cannot, depending on how you want to structure it, but I would say you can go and talk with them. You will find help and they will improve your idea. Because we are doctors, we are thinking about the practical things. But I'm not thinking about how I'm gonna design, how I'm gonna build it, which mold needs to be done. I'm not thinking about the FDA approval early on, and all these are steps they will help you to think about. I hope this answers your question.
No, I think this was the most pragmatic answer I've heard so far, and it's very important. I think it's the problem of innovation, the way I think of it, is the journey after you get an idea is blurred.
Yeah,
It's a big black box where it feels like one, it will take a decade at least to, see something come out of your idea. Second, you don't know where to start. And then third, there are so many threats to your time, to your investment already that I personally have not, put in a lot of thought or energy into innovation. I was talking to our prior guest, Dr. Akshantala, previously that for as a fellow, writing a paper is so much easier than thinking about a device that I think 90% of the fellows that I know of, maybe you know some who are more interested in innovation, generally end up just doing papers, doing their research, and complaining about their devices, and that's it. So
yeah,
I think this was a very pragmatic way where you started, and really like the idea about 3D printing because we had one of our advanced endoscopists who did come up with an idea about improving the exalt, I think, or one of the scopes had something lacking and he had come up with the idea. So he went for 3D printing. I know his journey. So what kind of investment are we looking at for the 3D printing part to get the prototypes?
sure. And I'm open about these numbers, honestly. So I went to an institute called Robert Seabird Institute. It's here in West Virginia.
Uh-huh.
The way I found them, they do summer school teaching 3D printing.
Mm,
And I went to them, and what we did is kind of an agreement where I paid, I don't have the exact number, but it be between 500 and $1,000
mm,
money to just improve my design, have the model on a software because that's what you need for a 3D printer, and 3D print a couple of models. So
okay,
it cost me roughly more than 500, but below $1,000. And these people, you can work with them online, but I'm sure you also have local people wherever you go who
right.
would be developing this. Yeah. So it's the Robert Seabird Institute in Huntington, West Virginia.
Nice. Yeah. I am involved in little innovation. I can't say these are my ideas,
Yeah.
but my mentor innovates a lot. And then I had the opportunity of testing some of those devices in the animal lab, which is why I know that how 3D printing is involved.
Yeah.
Some of the bigger institutes like Cleveland Clinic has their own engineering department, so I think from them it's straightforward. But similar to yours, like the place I am right now, Metro Health Case Western, we don't really have a direct access to a 3D printer. But in all honesty, I've never tried to find if we have a 3D printer.
Okay.
So
Yeah.
maybe we do, and I just don't know about it, and I need to just knock on some more doors.
Uh,
So go
I
ahead.
would say if you want to invest in your first 3D printer, and that would probably steer you away from doing more innovation. But if you are interested in investing in 3D printer, and I did now later on, a decent 3D printer is about $1,500.
Mm,
And you can start using it. The hard part is to learn how to use it. So actually, you spend months learning how to use it instead of actively developing your innovation. And I think one very good point you made, and I want to emphasize, we are in a system when we apply for our fellowships or residency, unfortunately, there is a number of publications you have to make. And innovation is a very slow process. So in terms of numbers, it will make your CV look thin, not thick. And you
right,
want to have all those papers that get published. And as of now, I literally don't, I've been working on my first device for almost 2 years and I don't have any publications. I have patents and things like that, but I don't have any publication.
right.
And that from an time investment standpoint for a resident or a fellow, that's a little bit scary, which I do understand. So you made a very, very good point there. And hopefully the system will change in the future to encourage more innovation.
Yeah. So coming back to your device, can you tell us more about that?
Sure. I was talking about how those first pain point in your early career are important. So, as we all have start doing passing the scope through the mouth, we always have a little bit of trouble, and then you learn. It's a fast learn. But I noticed that you might make your patient cough a little bit. Then during your endoscopy, there is always event of hypoxia. So I started looking into this, how we can fix this. And when I was doing colonoscopies and patients have obstructive sleep apnea, the anesthesia team was just putting a cannula in the mouth. And I tried to reproduce that in the patient's mouth. And I'm going to talk a little bit in simpler terms for someone who didn't do endoscopy. So when you're doing an endoscopy, this is a bite guard. This is not my invention. This is a regular piece from ConMed or from any company. And you can scope through it. The goal is to protect the scope and to protect the patient's teeth. And this piece, you have to put it before the patient goes to sleep. Otherwise, they will start fighting you when you try to put it on. And so many, many companies try to make this longer so it holds also the tongues forward to avoid the sleep apnea. And now you can easily guess the problem. They are causing a gag reflex if it's very long, or if it's very short, it's probably not effective. So I thought maybe we should be inventing a two-piece solution, and that's where I started with this invention. So I did this cannula where basically after the patient goes to sleep, this is in their mouth. And now before you put your scope in, you can put your cannula through it. It stays in there, it's stable, and now you can scope through it. So it's a very simple idea, but it did help. And now that we are doing the clinical trial, I can confirm that this is the right device, the right design, and it is safe, doesn't really cause trauma or anything. We were afraid it would be causing trauma in the back of the throat, things like that. It doesn't. So in terms of safety and design, I'm pretty confident in saying it's pretty good. And now I'm in the phase of trying to prove that it prevents hypoxia, and we are moving to the second stage of our clinical trial. And what's interesting also from a doctor to a doctor, when I say I'm trying to prevent hypoxia, everyone gets excited about it.
Right.
From an investment point, that's not what I say. I say I'm looking on how much OR time I'm reducing and I'm saving, because people have to look at it from a money standpoint. And this
Right.
is kind of things I'm learning through this process.
Right. No, this was amazing. So this
Thank
device,
you.
and it's small, it's elegant, but solves the problem. It's interesting because I recently learned this, but if in Korea, the gastroenterology fellows, or at least my mentor who was telling me, she had to undergo an upper endoscopy in her first year so that she understands how the patient feels. Isn't that crazy?
Interesting. I love it.
Um,
I love that. I love that. And it's good to try what your patient is going through. It's good. And I tried this device on myself too.
nice.
So
So,
it goes, I'm patient zero basically.
oh,
But
nice.
yeah.
You're the test patient.
Yeah, I was not included in the trial, of
Right.
course, because of the conflict of interest, but I was patient zero, and I tried my device on myself first after the cadaver
That's
testing.
awesome. No, so the thing about that was if when we are inserting the scope, she said we should do our best to not touch the palate
Hmm.
because the moment the palate is touched is when the patient has all the gag reflex,
Interesting.
sorry.
Okay.
So now my all my practice has changed. Like my big wheel goes all the way down just to, as a tongue depressor for the
Yeah.
scope to go in just to avoid the palate. But
Interesting.
this is a very elegant device. I really like it.
Thank you. Thank you.
So that's interesting. So now you're in your clinical trial stage.
Yes. I had a few, I would say I had few benefits from this device. I'm doing the clinical trial stage, which I had to learn how to design a clinical trial, how to pitch my idea also to the IRB because it's a very different ball game when you are introducing a new device.
Mhm.
I got a grant, and this is a training grant. It's an NIH funded grant. It's called the IRED, and this exists in every area of the US. So it's the regional entrepreneurship development, basically for medical devices. And
Wow.
this exists. I'm part of West Virginia, so I did the southeastern part, but this program exists throughout the US, and the goal is to have grants going to innovators. And I can tell you there is no shortage of grant for innovators. You can easily raise money. Money is not, if your university is not funding you, as
Mhm.
soon as you start having an idea, you can easily raise money. I haven't encountered the problem of not having enough money to develop things.
Mm.
Is there? There is way more money in grants for device innovation than for regular basic science research. So I
Mm.
had the grant. We developed and we are developing this device. But what was very unique with my grant, it came with the training lessons, and I'm still going through them, 4 months courses. And here, I think I want to emphasize something: the importance of your mentorship.
Mm.
Because if you don't choose the right mentorship, you won't be able to do this. And in the sense, you need a program director that allows you to have the time. Every Friday from 10 to noon, I'm not available because I have this class. Sometimes I have to go to meet engineer, things like that. All these people work from 8 to 5 jobs. That's when also you're working. You have to have a program that is flexible, helping you go in there. So that kind of mentorship that supports you in your time management and emotionally, kind of, I would say.
Mm.
And you need the other kind of mentorship, which is people who went through innovation and go through that. And I have the CEO of that company, Intermed Lab, I was talking about,
Mm.
who went through multiple stages of development, and I go to him for technical questions. But I would emphasize mentorship a lot, a lot. It changed, it at least saved me a year or two in what I'm doing right here.
Yeah, standing on the shoulder of giants. I totally agree that I think mentorship, you bring out very important points here because I think that's the other black hole, the black box that people feel support. That you may have ideas, and a lot of times people just don't have support. And as I'm hearing you, I can see how, my last 3 or 4 guests have all been about innovation. And then one of them was a purely academic setting. And by design, I wanted my next one to be in a private practice setting, just to understand how different it would be. And we were just very happy that you are here too. And
Mhm.
you would also be choosing your own setting in the future, right? Like
Yeah,
you're looking for jobs and stuff. So I think this is a very important point that you just made. Thank you.
thank you. Yeah, on your last guest, he was asking about who wants to innovate how to make a good basically anal or rectal plug so we can
Yeah,
do ESDs. And one of the things I'm subscribed to is FDA alert. Everyone can do that, and you can see whenever there is a new device approved. And I actually noted down. And a company just brought this to the market, and Dr. Andito was asking about it, and
right.
it's called the Air Assist, and it's done by the Gastro Concept. So someone answered the question he was asking
That's
in your
awesome.
last
That is
in your
awesome.
last
I am going to message him that if you can message me that, and I
yeah.
will subscribe to the FDA alerts.
Mhm.
That's actually very good. And that's how, and also in that point itself, and I've also been realizing this more and more, is we are not living in a silo, right? There are people around us smart people like you who are doing all these things, and including like ENT would be having similar problems, and I'm sure they have done some innovation on that front. And surgery does all these different things. Um, so just that, interdepartmental collaboration, I think it's very, very important. And
Yes.
more you do, the more you start to see. That's another thing. So just listening to you today, I think I'll start seeing my problems very differently for sure than I have been so far. So far, it has been a more of, oh, we can't do anything about it sort of an approach to it. But now I think it's very nice, motivating, inspiring to hear what you're saying.
Well, I think this podcast proves at least you have the brain for breaking some rules or trying to go in a path that no one has been. And so you definitely have the kind of personality for innovation. Like it's not easy to maintain a podcast like this. So you definitely have the kind of personality it takes to innovate because you need the personality that goes with it. And I can tell you do have it.
Thank you. So now you have the device. Now we discussed about the idea, the device. You've done your trial. Did briefly touch about patenting your device. You have a prototype. So what are your next steps? After, say, your device, you complete your trial, what are your next steps?
Yeah. So I just go back. I'll touch base one thing on prototyping, then I'll call. I'll tell you about the next step. So patenting and prototyping. So when you want to apply for a patent, what you want to do is apply initially for what we call a provisional patent, and that one will last you for 12 months.
Okay.
Provisional patent just kind of keep keep you in the queue and tells the world that I thought of this at that exact date, and hopefully that you're the first person who thought of it. Okay,
Mm-hmm.
but it's not public and no one has access to that application. That protects you for 12 months, and now you have 12 months to improve your design, work on your tool, and then you apply for a non-provisional patent. You can go right away for a non-provisional patent, but almost no one does that because we know you're gonna have some modification to your inventions. So you start with a provisional one, you have 12 months now to work actively and improve things and then apply. Price-wise is also very different. A non-provisional, a provisional patent will probably cost you between $5,000 to $8,000 in between lawyer application, everything. And the application itself is only $99. A non-provisional patent costs much, much more, depending on the complexity of your device, but it's definitely in the tens of thousands. So that's one thing to approach. Now, about the second stage, you're doing the clinical trial. As I tell everyone, my device has been on sale since the day I had a provisional patent. It has been on sale. It just gets more expensive every day. That's how I describe it, because every day I'm adding more value to it.
Mm.
So I'm always in the pursuit of hopefully selling it. And the reason for that, I'm a fellow and I want to keep more a doctor's career rather than creating a company and starting distribution if I can do that. I
Great.
might, but hopefully I won't have to get to that point. So every time I go to the DDW, I go to the ACG, now that I'm protected with my patent, I talk with all these device companies. And I can disclose specific names, but we negotiated with a couple big names. Unfortunately, it didn't get to the point where we signed a contract. But every time I go to these companies, I show my device and I try to talk with them. And a couple of them were interested. And even a rejection, or even if you're let's say you don't reach an agreement, you grow so much by talking with them because you sit when you go to any big company, you'll sit first with their engineering team, and they will kind of discuss with you your prototype, what tool you use, things like that, and that's always very interesting. And that stage is usually very good with my device because I know I have a good design. Now, where it gets a little bit dicey, and this is also a lesson for people to learn when I go to the financial team. So we have to talk of how much money a device will bring. This is a simple device. I'm not gonna, this is like a syringe, like an NG tube. You don't necessarily need an insurance approval for it. It's just part of the package for the endoscopy, okay?
Mhm.
So these small devices, unless you're selling a very high number, usually you won't reach a very big market cap or how much you're gonna bring money to the table with these.
Mm,
And that's one kind of small mistake I made here. I went with the simplest idea thinking, let me get it to the market. But once you start talking with investors, when you are talking about small $1 million a year, that's not that interesting for them. And this, I discovered this the hard way. So they really want to hear big, big numbers.
mm,
And that's not where I'm at. I'm more about, we do 6 million EGDs in the United States every year. If you try to capture half of those, you unless you're selling this device for 50 or $100, which won't be the case, you're not gonna bring a lot of money to the table. And that's where these companies, they all love the design, they think it improves things, but bigger companies don't feel like creating a whole department for a device that will only bring $5 or $10 million a year. It's
mm.
not worth it for them.
Interesting.
Yeah.
Wow. Yeah, and that's that's also a very, very interesting part because obviously, as you initially said, you have like 40 to 50 ideas.
Yeah.
Now with this knowledge and this knowledge, this experience that you have, would you sort of triage your ideas based on that also? Like how big and how common the problem you're solving?
Yeah. Uh, well, yeah, it's a very good question. And unless you go through the whole stages of a device like I'm going through, I don't think you'll get it right, necessarily right the first time.
Right.
But the main questions ask yourself, how much money is this going to bring? And you have to be honest about it, understand the pricing, understand how many hospitals will buy it from you, things like this. And this is our small studies. I'm not talking about recruiting consultant. That will come at a later stage.
Right.
But understand at least it's bringing tens of $1 millions potentially.
Mm.
While you're answering that, if it does, is it simple enough for you to make it? And is
Right.
it simple enough for you, for the resources you have to make it? If you are in a very big university, you can go as complex as you want. They will make it happen for you. If you are in the smaller settings,
Mm.
you have to understand the limitation of the resources you have around you. So can you make the device and will it be bringing enough money? And let's say you answer those two questions. Another thing you have to do, is there any prior art or prior patents?
Right.
To pay a lawyer to look into freedom to operate is $50,000. To do small research for you is probably around $5,000. But what you can do on your own, you go on Google Patent, or you go on the US trademark office, basically website, and look into patents. And
Mm.
I did that early on. And that actually helped me improve my device because I saw what I described very early on, how people try to do a single piece where they try to elongate the bite guard. And I realized many people thought of that. And
Mm.
then I thought, why didn't it work? And probably the gag reflex. Well, let's think of the two-piece solution. And I didn't find anyone doing that.
Right.
So looking into patents will not only help you protect your idea, but will help you find new ideas. And you have to understand if people patented the same idea you have, why they didn't pursue it. It was probably either money, they didn't, or they weren't interested, what happened. But usually if you reach the stage of a patent, you are pretty motivated to make it happen. So there must have been some issues why it didn't get to the market, and you have to understand why that happened.
Right.
So these two search engines are very, very helpful for you too. So if you answer the question, how much money you're bringing to the table, if it's feasible, there is no patent before you.
Mm.
Now, I think that's enough answers to start working on your idea. There is still way more questions, but I don't want you also to be paralyzed.
Right.
Just answer these few questions. If you feel like you can build something, start working on it.
Right. Yeah. And I think from everybody that's listening, and an advice to myself too, is start small.
Yeah,
Because once we also start thinking about all those things in the end, it does not become that fun. It does not
yeah,
remain that fun, I should say. So I think start small and then big things happen. There's this very interesting podcast slash educational series on YouTube. So Dr. Ben Moeller talks about his innovation of Axios, and the Axios stent has been a game changer, right? Now Axios are flying and going through the bile duct and gallbladder and everywhere. But he also has 50 other patents or more than
yeah,
50. So there were so many innovations and then one masterpiece, but there are other smaller innovations too. I think the first ampulectomy was also done by him. So
Yeah.
gradually build your portfolio. It's just like doing studies, I believe. So congratulations again. Masterwork.
Thank you.
Very inspiring.
Thank you. Thank you. Well, the Axis is one of the success story we'd love to hear about. They sold it for $65 million plus $12 million after FDA approval. So it's a pretty nice success story. I'm not sure how much the initial inventor got because he probably had gave more equities to other
Right,
investors, but it's definitely one of the success stories now is widely available. So they not only made money with it, but they are helping so many patients with it.
right,
And that's what you want to hear, right? When
right.
money and patient's interest align, and you have to find that sweet spot in your device.
Yeah. I wish I could keep talking, Dr. Turkey, and this is all golden nuggets. I'm sure we're going to meet again soon and hope to get you on my podcast again. But this would be it for now. So thank you so much for joining us today.
Thank you for having me.
Thank you.